in a database. And inside that database, we talk to the database using SQL, and all the data is actually stored here, and the magic happens. The data server is that database software that's so precious and valuable. And then there's another person, often called the database administrator, who has direct access to the data. And these roles in medium and large projects are kept separate, mostly because the production, while it's running and live, the developer leaves the data alone and works on, say, the next version of the software. And then the developer has a test version of the application that they run on their computer where they're doing all that stuff. And so this database administrator is a role in a large project where we have to run production and keep production careful, keep production in good shape. So the database administrator has this responsibility for the production aspects of the data, and you may be working in a situation where you're not actually controlling the data. The database server is on different computers, you have little special access, and you write programs to sort of read the data, and so the database administrator is the person who is asked by the organization to administer that data. The data that we develop, and we'll do this in the second part of these lectures, conforms to a data model. That's the metadata. Is this an integer? Is this a string? You know, how many columns is this? And the data model turns out to be very, very important. And there's a lot of science to building an effective data model that leads to really good performance. And it's a collaborative activity between the application developers and the database administrator to make it so it's efficient, runs in production, etc., etc., etc. There's a lot of products out there that you may encounter. We're going to be using SQLite. SQLite's a little tiny database server, and it's built into so many things, and that's why we like it. But if you're going to work at a large organization, you could easily run into Oracle, which is the #1 commercial product. Microsoft has a thing called SQL Server, which is a commercial product, and it's also very popular and very effective. The more popular open source, there's things called Postgres, there's MySQL, and MySQL recently was sort of bought by Oracle. And there is a copy of that called MariaDB that doesn't belong to Oracle, MariaDB. And so most of the SQL that we're going to learn is common across these database systems because SQL is a standard, but then there are parts that weren't part of the original standard where each database vendor has done things a little bit different. But there is a core common subset that does the basic create, read, update, and delete operations. So SQLite is very popular. You probably have it in your cell phone 10, 12 times. Your web browser has a database engine in it. Your car has a few databases in it. And so SQLite is what's called an embedded database system. Python comes built in with it. You just import SQLite 3 and away you go. And so it's very, very popular because it's free, it's open source, and it's such a tiny little piece of software that you just include it in other pieces of software and use it to solve the data management problems of those pieces of software. Like your browser might use SQLite to store your bookmarks. Now you think, oh, there's only how many bookmarks can you have? But what if you need it to be fast? And what if there's like people that have 10,000 bookmarks? There probably are. Do you still want it fast? Do you want to be able to search? And so you get all that by using a database like SQLite. And so again, we're going to encourage you to download the SQLite browser so you can follow along with what we're going to do coming up next. And so here is the SQLite browser. Here's what it looks like. And it's just a desktop application. And coming up next, we'll start playing with this desktop application and see how it works. So now we're going to make a database. We're going to use SQLite browser. Hopefully you've downloaded it so you can follow along. And I've got this handout. This basic database handout that saves you from having to type all these things, so bring that up in your web browser. And so that gives you all of the commands that I'm going to type now. And so you could pull them out of the either the web page, you can pull them out of the slides, or you can pull them out of that. So I'm going to bring up the database browser here. Database browser. Now, the thing that's going to happen, you'll see this happen on my desktop. I'm going to make a new database, and you have to store it somewhere. And so I'm going to put it on my desktop, and I'm going to call it PY4E Fun. And so we should see a new file on my database right there, py4efun. Now that's a file that you don't want to edit with a text editor or anything like that. This is a database that this is a file that's to be read by SQLite browser and nothing else. Okay, so we're going to create a table, and I'm going to make a table called users with a column called name that's a text and a column called email. So it's already asking me to make a table. I'm going to call this users, and I'm going to add a field that is called name, and I'm going to add a text, and I'm going to add another field called email, and I'm going to make that be text. Now the key thing here is we are in effect making columns and rendering an opinion as to exactly what that column is supposed to be used for, and we're not allowed to violate that. It's not like, oh, we'll do whatever you want, because the database is optimizing its storage based on a contract that we're effectively making the contract ourselves. We could make these columns anything we wanted, but we're going to contract with ourselves. And you can see it's kind of small here. You can see there's a create table, and that's on the slide, and that's the SQL way of doing that. This user interface is just helping us write SQL. So now I'm going to just say OK, and if you take a look, you can see that I now have a table users, and I can look at my database structure, the table users, and away we go. And so now that is creating it, and like I said, here in the slides is the create statement, or on the web page there's the create statement that could have done it. Now we can insert some data. Let's add a new record to this database users, and we'll call this guy name Charles csev at umich.edu. So now we have a record. So it's kind of like a database, a spreadsheet. Now that's not the SQL way to do it. There's SQL sort of going on in the background. But if we really want to do this using SQL, we're going to use the insert statement. And the insert statement looks like this. The SQL syntax sometimes has extra words. Insert into is actually two SQL keywords. The name of a table, the columns, and then the word values, and then one-to-one correspondence between the values and in parentheses. So it looks kind of like a tuple in Python, but we're nowhere near Python right now. Okay, and so that's what we're going to do. And so I'm going to grab this Kristen, and I'm going to go over here to my SQLite browser and say execute SQL. So now I can say paste that in and then hit this little run button, and that's going to submit the SQL to SQLite and then update that file, and it says query executed successfully, and away we go. So if I go back now and I look at the data, I see that there's two things in here, and now I can actually insert all the rest of these. Let's go back to my little bit of stuff here. Let's put all these other rows in. It turns out that if I go into the execute SQL and I want to do more than one command at a time, I can put a semicolon at the end of each one of these things, and then I can run them all all at the same time. I mean, one after another actually is what's going on here. So boom, 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 and now I take a look at the data, and look, I've got all those things in there. Now, eventually, the thing that's going to generate that SQL is a program, not us. We're being the database administrator, so we're sort of doing things manually. Once things get going, you write programs, do that insert over and over and over again in Python or a web language like PHP or something like that. And so that is the insert. Now we can get rid of data. And so I'm going to say delete from, that's the keyword, users is the name of a table, where is a where clause. We'll have lots of where clauses in SQL, which is, it's not like an if, in effect the delete is going towards the whole table and being turned on and off by this where clause. So delete from users, if you didn't put the where clause on, will actually delete all the rows. But where ted equals, email equals ted at umich.edu, well, that one is going to make it so it only applies to the rows where that is true. So I'm going to go over here in SQL, and I'm going to say delete from users where email equals ted at umich.edu, and then I'm going to run it. Because it's only one, I don't need a semicolon at the end of it. And now if I go back and I look at the data, Ted is gone. Okay? Update. So the update says